We started this course by talking about how logic would help us evaluate arguments. And in this lesson, we'll finally learn how we can use truth tables to judge whether an argument expressed in truth functional logic is one that's valid or invalid. So the goals of this lesson will be to learn to use a truth table to determine whether a set of sentences in truth functional logic entails another sentence. You should be able to use a truth table to judge whether an argument is valid or invalid in truth functional logic, and have a sense of what the relationship is between entailment and validity. Remember from our first lesson that the aim of constructing a good deductive argument is to have the conclusion follow from the premises. Entailment is a way of capturing that notion of following from. So a set of sentences A1, A2 through AN, substitute any sentences for those A's of something in truth functional logic. That set of sentences entails a sentence C, the conclusion, if C follows from A1 through AN. With a truth table, we can show that A1, A2 to AN entail some sentence C if and only if there is no valuation that makes all of A1 through AN true and C false. Another way of thinking about this is that when the sentences A1 through AN entail C, then in every one of the valuations, the rows of the truth table, where A1 through AN are true, C will also have to be true. We can use that concept of entailment to define what makes arguments valid or invalid and set up a test for validity and invalidity using truth tables. So take this set of sentences A1 through AN. That's going to be our arbitrary number of premises. They entail some sentence C. If that's the case, then we can set them up in this way characteristic of an argument with the premises first, followed by the conclusion. And if A1 through AN entail C, then we have a valid argument in truth functional logic. Again, you may want to review this concept of validity and invalidity from the first unit of the course. If, on the other hand, the sentences A1 through AN don't entail C, then the argument is invalid in truth functional logic. That discussion was probably a little bit on the abstract side. So let's look at a concrete example of what this means when we use a truth table. How do we use those definitions to run a test? So, a question you would see is something like this. Is the following argument of truth functional logic valid or invalid? And we see that argument to the left here. Our premises are P or Q, and if P, then Q. The conclusion is just Q. The procedure we'll use is the following. First, you have to complete the whole truth table. We'll look at that in a moment. Then, you would look at the truth values of the last three sentences. The premises are your A1 through AN, and the conclusion is that C. So what the definition said is if there's no row where the premises, A1 through AN, are true, and the conclusion, that symbol C, is false, then the argument will be valid. But if there is a row where the premises are true and the conclusion is false, the argument will be invalid. So already to the right here, I have the structure of the truth table set up. This should be pretty familiar from what we did in the previous video with multiple sentences. It's just that here we have to pay attention to the difference between the premises and the conclusion. So the first two columns are for the two simple sentences, P and Q, that appear in the argument. Those are the only two. After that, we have to list each in a separate column the three sentences of the argument. P or Q, the first premise, if P, then Q, the second premise, and Q, the conclusion. It's important to relist Q to signal that it's the conclusion, all the way to the rightmost column. You're also welcome to mark it in some other way that signals it's the conclusion. As usual, we'll start with the columns under our simple sentence letters, just as you would do for a single sentence or a set of sentences that wasn't an argument. So we've got true, true, false, false under P, and true, false under Q. Each of these sentences in the argument contains at most one connective, so determining their truth values is relatively straightforward. So we determine the truth value of each sentence of the argument as you would do for each single sentence individually. In the first premise, we see that it's a disjunction. The disjunction is true as long as one disjunct is true, so it's only false in that last row. For the second premise, the conditional is only false when the antecedent is true and the consequent is false. So it's true other than in that second row. And for the conclusion, I've copied over the truth values of Q so we can easily mark it as the conclusion and see the truth values written again. Our truth table is now complete. We have the truth value of each sentence in the argument completed. So now we can use it to judge whether the argument made up of these three sentences, P or Q, if P, then Q, those were our premises, and Q is the conclusion, if that argument is valid or invalid. To do that, we need to look row by row at the truth value of the sentences in those last three columns, the premises and the conclusion, because those are the ones that make up the argument. In the first row, the conclusion is true, and so are both of the premises. So that passes our test for entailment, and we mark it with a check. The next row has a false conclusion, but the second premise is also false. So again, it's compatible with our definition of entailment. We don't have true premises and a false conclusion. We have a false conclusion, but also one false premise. Similarly for the third and fourth rows, so we can check those off as well. Since there is no row where the two premises are true and the conclusion is false, this is a valid argument. Those premises entail that conclusion. Let's look at a second example just to get you familiar with this process. So here our premises are the negation of P and Q. If not Q, then P. And the conclusion is P. Again, I've set up the structure of the truth table, so we have to complete it to get the truth value of each sentence of the argument on each valuation, and then run our test for validity and invalidity. The first two columns look just like before, since again, if we look in this argument, there are only two different simple sentence letters that appear throughout the argument, P and Q. So to get the truth value of these premises, we should note that both of them each have multiple connectives. So to get the truth value of the whole sentence, we have to start with that narrowest scope connective and work our way outward to the connective with widest scope, the main connective, to get the truth value of the whole sentence. The narrowest scope connective in each of the two premises is marked here in orange. For the conjunction in premise 1, we look at the truth values of both P and Q in the first two columns to get that the conjunction is only true when both conjuncts are true. And for the negation in premise 2, we just look at the column for Q. Now there's only one other connective in each of those sentences, so we can determine the truth values of those sentences by determining the truth value under the main connective, the one we hadn't addressed yet, here color-coded in red. The truth values of these main connectives depend on the truth values of the connectives in orange that took narrower scope. So in the first premise, the negation applies to the conjunction. So to get the column in red for the first premise, we take the negation of the orange column. And in the second premise, we need the truth value of the antecedent, not Q, to get the truth value of the whole conditional. I also copied over the truth value of P just to make it easy to see how we get the truth value of the conditional. And it's only false when the antecedent is true and the consequent is false. So we see in that last row, not Q is true, but P is false, so the conditional in red is false. The final column of the truth table copies the value of P, just like we did in the previous example, though the conclusion won't always be a simple sentence letter. And just like in our previous example, we need to go row by row to see whether or not there is one where the premises are true and the conclusion is false. The first two columns have true conclusions. They can't fail our test, and we can mark them with checks. Right? They pass for entailment. But the third column has a false conclusion. This means we need to check if both premises are true, because if they are, this means the argument fails our entailment test. Looking under the main connective, again in red, for each of those premises, we see that in the third row, the first premise, not P and Q, is true, and the second premise, if not Q, then P, is also true, while the conclusion is false. That shows that this set of sentences fails our entailment test. So I've marked it here with an X. This shows the conclusion is not entailed by the premises, since it can be false when the premises are true. That means that the argument is invalid. So since there's a row where the premises are true and the conclusion is false, just one row, that's enough to show that the whole argument is invalid. So you now have the tools to use truth tables to evaluate arguments. In the next videos, we'll look at a few ways to shorten and simplify our truth table procedures that will make our lives a little bit easier.